Okay, and it's because it allows us to prove two lines are parallel. But first, we're going to do these theorems, then we're going to go to the converse. So postulate 10, this is very important, tells us that if two parallel lines are cut by a transversal, so these are parallel lines, okay? These little marks, these little arrows, tell me these are parallel. Notice I didn't even put my arrows out here. The book still puts the arrows out here, but if you have arrows like this in the middle of the line and they match, that tells you those lines are parallel. If I had another parallel line there, I might put two sets on that pair to show that those two lines are parallel. Okay? So that's a new notation. If you see that, that means parallel. Now, if two parallel lines are cut by a transversal, then corresponding angles are congruent. That's why it's so important to know what corresponding angles are. So remember, 6 and 2 are corresponding. They're both above the line and to the right of the transversal. 4 and 8 are corresponding, both below their lines and to the right of the transversal. So 4 and 8 are congruent. 2 and 6 are congruent. 7 and 3 and 1 and 5, they're all congruent. Very important. So that's a postulate. Now, we're going to use all of these. This talks about alternate interior angles. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So not only are corresponding angles congruent, alternate interior. So 3 and 6 and 4 and 5. Okay, yeah.
Wouldn't 1 and 4 and 2 and 3 also be
because of vertical, or 1 and 4 would be congruent because of vertical angle.
And 2 and 3 also, right?
And 2 and 3 because of the vertical angle definition. Okay, so that's right. So we're going to use all of that in our exercises. So that's good that you remember that. Okay, so we've got our alternate interior. Same side interior angles, so that would be like 4 and 6, are supplementary. That makes sense because if we know that 6 and 2, they're corresponding, we know they're congruent. Well, this is supplementary to 2, so it must be supplementary to 6, right? Okay. So same side interior angles are supplementary, they add to 180. Now, if a transversal is perpendicular, that's this picture down here, to one of two parallel lines, then it's perpendicular to the other. So in here, n is perpendicular to 1 because we have our box. But we know these two are parallel because of our markings, so then we know that n must be perpendicular to line M. Angle 5 is 65 degrees. So what's the measure of angle 6? And maybe we won't even use what we learned today. What's the measure of angle 6?
65.
65 because they're vertical angles. So we know that. Okay? That does not look like 65. All right. So if we know these, what do we know about the angle measure 7? I mean the measure of angle 7.
You have to add up 65.
These have to add, they're supplementary, right?
Yeah.
So they have to add to 180.
180.
So this has to be
180 minus 65.
115, right?
Yeah.
Okay. So this is 65. This is 115. These are like puzzles. So what about the measure of angle 8? So I've kind of turned our little diagram on its side. Now these are our parallel lines. This is our transversal. So our alternate interior are going to be these and these. Our same side interior are going to be these and these. And our corresponding angles are going to be here and here and here and here. So what do we know about angle 8?
Wouldn't it also be 65?
65 because it's corresponding. And because of our postulate 10, corresponding angles are congruent. Excellent. Okay, now the measure of angle 9. What would that be?
115.
115 because they're supplementary. Oh, and this said to tell which postulate. So with the measure of angle 6, we use the definition of vertical angles for Measure of angle 7, we used the definition of supplementary. Here we used our postulate 10, which is that corresponding angles are congruent when you have a parallel line. Angles are congruent. Okay. Oh, let me put the little congruent sign. It's easy. And then the measure of angle 9 was 115. Well, that was the definition of supplementary again. We get to the converse, and this is where it's these that we can use to start proving two lines are parallel. Okay, so first of all, we have the converse of postulate 10. You remember what a converse is? We've got our if in the end, then, and we exchange them. So the hypothesis and the conclusion get exchanged. So now we're saying if two lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. So we can work backwards. Similarly, if the alternate or interior angles are congruent, the lines are parallel. If the same side interior angles are supplementary, the lines are parallel. If two lines are perpendicular to the same line, then they're parallel. Okay? So, these 5 things, these 4 that I just talked about, plus this one, which I'll talk about in a second, can be used to prove two lines are parallel. So if you're asked in your homework or on your test to prove that two lines are parallel, you're always going to be going back to these converse statements. The last one is if two lines are parallel to a third line, then they're parallel to each other. Okay, now. Okay, so we're trying to prove, we're seeing if we can prove that A and B are parallel. Okay, so are they parallel? What do we know?
The line going in between is transversal.
This is our transversal, good. So these would be same side interior, right?
Yeah.
So does that help us? Same side interior angles have to be what for the lines to be parallel? Not congruent, but supplementary. And are these, do these add to 180? They do. So these are, so it's yes, because of same side interior angles are supplementary. So now we know those lines are parallel. What about number 14? Can we prove that A and B are parallel? No, because we know B is at a right angle, but that only helps us if A is at a right angle. And we've just got B being at a right angle twice. So we can't prove anything there. This could be slightly off. We don't know. Okay. What about these?
54 and 49.
So 54 and 49, we can see what those add up to. That adds up to 103. So this angle is 103. Does that help us?
No.
No, because, well, that means this angle is 103, right? And these are corresponding angles. They'd have to be congruent in order for these to be parallel. So no. If this was 106, then we could say these were parallel. Does this make sense? Are you following?
Yeah.
Good. Okay. Now, here we've got 2 more. We're trying to prove that they're parallel. Let's see what we've got. Should we try adding them up again? This angle here, whoops. This angle adds to 114 degrees. Does that help us?
No.
No.
Oh wait, yeah.
What can we get from that?
Because it's 114.
This one?
Yeah.
Because it's a vertical angle. And then these are,
Supplementary. Or
that would be this and this.
congruent.
Congruent. They're corresponding angles, and if corresponding angles are congruent, then our lines are parallel. Make sense?
Mm-hmm.
Yeah, it's a lot to get used to. That's why on this one it's really important to do the homework, the practice. Okay. What do we know here? And by the way, if you extend these line segments, this could be a transversal, or this one could be a transversal, okay? If you extend it. So sometimes you have to use your imagination. What if we have just that one is a transversal? What if we're just worrying about this one? Do we know anything that we can use?
They're all 60 degrees.
They're all 60 degrees. Do we know anything about angles that'll help us with our, we need to know either alternate interior or same side interior or corresponding. So do we have any of those?
I think alternate interior.
Alternate interiors. So we have, well, we have this one, but we don't have one over here. And then we have this, which is 120, but we don't have one over there. So we don't quite have alternate interior. Do we have same side interior?
No.
Yeah.
120 and 60. Those are the same side and they're on the interior. And they do add to 180. So there you go. So yes, because of same side interior angles.
It has a right angle.
It has a right angle, so this is 90. And this is 60. What do you know about this? Remember the three angles of a triangle, what they have to add to?
180.
180, so this has to be 30. So what are these? If this is your transversal, because it doesn't have to be the one with the arrows on it. If that's your transversal, these are what? They're both on the interior. What kind of interior angles are they?
6.
Are they on the same side of the transversal?
Yes.
Or are they on opposite sides of the transversal?
Oh, sorry, opposite.
Yes, so they're alternate interior. And alternate interior angles have to be congruent. And they're not, right? They're not. Whoops. Okay. So, no, we can't prove those.